All right, everybody. Welcome my talk, ES 2016, the Evolution of JavaScript. First, a little bit about me. My name is Jafar Husain. I'm a tech lead at Netflix. I'm the architect of Falcor, which is an upcoming UI data platform, which Netflix plans to release, open source pretty soon. I got about 6 years of experience writing reactive systems, and I'll be talking a little bit about that later. And I'm also one of Netflix's representatives on the TC39, which is the JavaScript Standards Committee. So this talk actually used to be called ES7, the Evolution of JavaScript, but something happened a couple of committee meetings ago. We decided to change the name of ES6 to ES 2015 and ES7 to ES 2016. Now, there was a little bit of controversy about this, but I want to explain this name change. The idea is that we as a committee want to start shipping JavaScript every year. We want to move to a feature train model, so just the way you would ship software in an agile way, we want to be able to add new features and ship them quickly. And so that's part of why we have this rename. So what you formerly knew is, the language formerly known as ES6 is now known as ES 2015, and the upcoming language version is known as ES 2016. So ES 2016 features are already starting to roll in the browsers. So for example, there's Object Observe in Chrome right now. And it's important to know that ES 2015 and ES 2016 were developed concurrently. So although there was this big, many years between ES5 and ES 2015, what the committee is doing is they're developing new features in the latest version of the language at the same time as they're developing features in the next version of the language. And that's exciting because it actually helps us plan about the future of JavaScript. We don't have to do everything in one release. We can add features today to ES 2015, and we can build on them, right, with the hopes of building on them later in ES 2016. And so the real question I want to talk to you, I think the big story about ES 2016 is how do we make async programming easier? I think there's probably some folks out there who think this is kind of a hard problem, right? Any pain out there about async programming? Yeah, quite a few people, I'm guessing. So starting with ES5, we introduced something to make your life just a little bit easier, which is arrow functions. I'm not going to dwell on this too long, but as of ES6, or ES 2015, I guess, you'll now be able to rewrite this way. I think most people in this room are familiar with arrow functions by this point. You can sort of get rid of the boilerplate. I'm not going to spend too long on this. This definitely helps out when you've got a lot of callbacks in your code and you're doing async programming. Arrow functions are an improvement, but can we do better? What if you could write async programs without any callbacks at all? How does that sound? Yeah. Right? Yeah? So we all know that blocking is easy, right? Blocking's no problem. Blocking, let's imagine for a moment, this function which gets a stock price calls getStockSymbol, which makes a blocking XHR request. One of those things us UI developers are never supposed to do. We're never supposed to make a blocking XHR request, right? But it sure is easy, because then we can just wait for that request to come back and block until it does, and then go ahead and pass the name of the symbol for that stock and get the price for it. So we know that blocking is easy, but it produces a terrible user experience. Because our user might be sitting there and our UI is not responding to mouse clicks while we're sort of going off and making that async request. So that's the type of thing you're not supposed to do in JavaScript. Now from now on, when I say the word blocking, what I want you to think is pulling. What we're really doing when we call a function and we receive the output in the return position of that function, and we're sort of blocking and waiting, is we're kind of like pulling the value out of that function. To the left-hand side, we're pulling the value out. So when I say blocking, I mean pulling, and what that means is data is delivered in the return position of the function. That's how most functions are in JavaScript. Most functions return their data in the return position. But what if we decide that we want to wait instead of block? We don't want to block the UI, waiting for the output, and not being able to respond to user input. We want to be able to just wait. Well, in order to wait in JavaScript, waiting means pushing. What it means is you hand a callback to that function, and that function pushes the value, the result of that function, in the argument position of your callback. So here's a typical type of thing that you would see in Node, right? You hand a function a callback, and it pushes the value, the result, in the argument position. So as soon as we try to do that, as soon as we try to wait in JavaScript, we very rapidly find ourselves in the pyramid of doom. If you've done a lot of Node.js programming, you probably know what I mean. Your code takes on this pyramid-like structure that you see there on the left-hand side. So on the left-hand side here with getStockPrice, we're doing a blocking function. And we're just the same function you saw earlier. But as soon as we want to move to waiting on the right-hand side, take a look at how much more complicated our function becomes. Why is there so much more code here? Well, for one thing, it's because we're doing the job that JavaScript usually does for us. If an error is encountered anywhere in this function, right, now as soon as we're using callbacks to forward on those errors, we're responsible for making sure that those errors get forwarded up. Whereas when we're doing blocking code, we have try-catch to rely on. So as soon as, the problem really what's going on here is that since JavaScript doesn't expect functions to wait, in JavaScript, they sort of expect functions to block, well, there's no support for reporting errors this way, and the language can't provide you with any sort of support, whether it's loops or try-catch, so you're kind of on your own. But what if waiting were just as easy as blocking? What if JavaScript understood this concept of functions that waited, and it could provide you syntactical support, just like try-catch, and you could use loops, for example, to repeat asynchronous functions? Well, in ES 2015, we got a little closer to this vision with promises. Right? Now, the way I think most of you are probably familiar out there with promises is I think most people have been exposed to them at this point. But the way to think about a promise is that it's an object that represents the eventual value from an asynchronous operation. And so if you want to get the value out of a promise, you call then, and you pass in two callbacks. One is for receiving data if the asynchronous operation succeeded. So that's the one on the left-hand side there. And the other callback is for receiving the error if that asynchronous operation failed. And so it's sort of like a promise is like a present that you unwrap, and great, if everything worked out, you get a value. But if things go bad, you can get an error. So now let's take a look at that same previous example, waiting with callbacks and that pyramid of doom structure that you see there, and let's see how we can now do the same thing with promises. So what's happened here is promises actually take care, they catch any errors that occur and forward them up until they're actually caught, where we pass an error handler. Notice there on getStockPrice, we pass an error handler. We don't have to catch errors at every possible step in the function. We just catch errors in one place, and the promise type will catch the errors and forward it up until there's a function provided to handle that error. So what's actually happening is the type is doing the job that try-catch does for you in the language. And so that's how we got back down to that nice little piece of code. So that's quite an improvement. No more pyramid of doom. It's not bad, but why can't we just write code that looks pretty much the same, regardless of whether it's waiting or blocking, right? What if we could just write our algorithm and then make it really easy to switch that algorithm between waiting and blocking? That promise code you saw on the previous slide still looks pretty darn different than the synchronous blocking code that you saw earlier. Well, as of ES 2015, you will now be able to wait like this. So using generator functions and the yield keyword, which is something I'm going to tell you about later, you can actually write code that looks pretty much exactly like the blocking code, but instead waits. It doesn't block. And so you can allow handling of user input, but you can write your code top to bottom. Furthermore, you can even take advantage, just like in blocking code, of looping constructs to now control flow in an asynchronous program. So now here over on the right-hand side, I can use loops, and I can even use try-catch. So how does this work? How do we make this work in JavaScript? Well, in order to explain that to you, I'm going to have to explain generators. But I think the meta point that I want you guys to understand here is that pulling and pushing are asynchronous. Or excuse me, are symmetrical. You can do the exact same thing. You can write your code precisely the same way, whether it's pulling or pushing. It's kind of a detail. You should just be able to write your logic and then after the fact decide whether you want that function to push or whether you want it to be a pulling function. Anything that you can push, you can pull out of a function. I'm going to demonstrate that in just a moment. So in order to understand how that works, I'm going to explain to you the most powerful and most misunderstood feature in ES 2015, and that is generator functions. Hands up, quick. How many people have heard of generator functions? Okay, great. Quite a few people. How many people understand them? Right, okay. So that's hopefully what I want to rectify today. If you get one thing out of this talk, it'll at least have a slightly better understanding of what generator functions are, because I said they're really powerful. So here's, at a high level, this is how I want you to think about generator functions. It's a function that can return multiple values. Well, you can already make a function that returns multiple values, right? You throw a few values in an array, and then you return that. Well, generator functions can allow you to do that a little bit more efficiently in some cases. So this is what a generator function looks like in ES 2015. And for now, the mental model I want you to use to understand this yield keyword is that's sort of like an intermediary return. It's like a return statement, but it just sort of, runs in the middle, and you can return more values. So if you're consuming the data from a generator function, this is what it looks like. In order to get the data out, you request an iterator. By calling that function, what comes out is an iterator. An iterator is something that you can call next on, and then what happens is the function evaluates to the first yield and then stops and returns that value. And then it pops out of this little tuple, which contains the value that was returned and a Boolean telling you whether or not there are more values. So if done is false, we know that we can call next again. And I want you to look on the left-hand side. Execution is going to resume and move to the next yield and then pause. And then return you another tuple saying that value. We know that we still have more to do, so I'm going to keep calling yield, or next, until finally we get to return, and then we get our last value. And we know we're done because done is true. Now imagine we didn't have all this magic, right? If I wanted you to write a get numbers function today in ES5 that did this, you'd probably roll a state machine, right? Something that just keeps track of where you are, and every single time I call next, I get the next value. And so to see how that works, let's take a look at this Fibonacci sequence function right here. And I'm going to show you what it desugars to from ES 2015 to ES5. So what's going on is you can see I've got this state variable on the left-hand side, and that's keeping track of where I am. And notice I'm returning this object with the next method. That's the iterator that you saw earlier. Right? Now, what this function actually is doing, as you can see here, what generator functions do is they figure out every possible state that that function can be in, and they build a state machine. And so basically, this get Fibonacci sequence can be in 3 different states when you call next. It can be in the state where it's supposed to return 0 at the very beginning, the state where it's supposed to return 1, and then finally the state where it's just supposed to take whatever it returned last time and whatever it returned the time before that, add them together, and then return it. In JavaScript, in ES 2015, this generator function is actually smart enough to figure that out and build this state machine for you. And what it's really doing is it's turning what looks like a push. Notice on the on the left-hand side here, yield kind of looks like a push. Imagine yield was a callback, right? And there was brackets around that yield. The code looks like we're pushing the data, but the compiler turns it into code that polls by building a state machine on the left-hand side. So that's effectively what generator functions do. They let you write code that looks like you're pushing information, when in fact, it turns it inside out, and then it uses poll for the control flow. So for each one of these yields, we have that little return, which returns the tuple, the value, and the done. And it increments this state variable as it goes along, and then that's how we move through the states. So this allows us to use a pattern called iteration. This whole process of getting an iterator and pulling a value out of it and pulling a value out of it until you're done is called iteration. And iteration involves a consumer and a producer. And the way it works is a consumer requests an iterator from the producer, and then it pulls the value out by calling next. So the producer emits a value, right? And why do I say it's pull? Well, notice I'm getting the value out in the return position of next. So I'm pulling functions out. I'm pulling values out. So I keep pulling values out until finally I pull out a value and the producer says you're done. So that's how iteration works. You keep pulling values out until the producer says, I'm done, no more data. So if generator functions return iterators, why are they called generator functions? Why don't we just call them iterator functions? Well, there's more than meets to the eye when it comes to generator functions. A generator is actually built out of 2 different interfaces. So the iterator, which you guys saw earlier, where you can call next and get out that little tuple saying whether you have what the value is and whether you're done. But it also has an entirely other side. It's like got a split personality, which is an observer interface, which gets pushed values. So a generator is both a source of data, which you can pull data out of, but it's also a sink, which you can push data into. So these 2 interfaces combined create a generator. So a generator is an iterator, so you can pull a value out. If you attempt to pull a value out, you can get an error, right? Because it might throw when you call next. And finally, you can pull a value out and get that done : true in that little tuple. So there's really 3 types of notifications that a producer can tell you during iteration. I've got some data, an error occurred, and here's your final value. Well, you can see all of those notifications in reverse on the observer side. So when you call next on a generator, you can also push a value in by passing a value in the argument position of next. You can also send an error in by calling throw. And finally, you can send in a final value by calling return. So why does an observer have this sort of split personality of both being a source of data and sink? Well, it's to solve a little problem. And that's that iteration only allows data to flow in one direction. Whereas with generators, 2 functions can effectively have a conversation, have a long-running conversation. I pull a value out, I push a value back in. I pull a value out, I push a value back in. Why would I want to do that? What does that buy me? Well, it allows us to use a very powerful pattern that I think a lot of the people in this room are going to be using in the next few years, called asynchronous iteration. So here we have our generator function, and the first thing I want you to notice about this generator function is that I told you to use a mental model for understanding yield. The mental model I gave you was, it's sort of like an intermediary return, right? But in this particular piece of code, yield seems to be used like an expression, right? We're assigning to the result of a yield. So what's that about? Well, here we have a producer function, and what it's actually going to produce, if you notice what's on the right-hand side of those yields, it's going to be an iterator of promises. So we're going to pull promises out of this iterator, and then what we're going to do is we're going to resolve those promises and then push the value back in. And so we need a consumer to go along with this producer. The consumer's job is just going to be to pull out, by calling next, pull out promises, resolve those promises, and then push the value back in. And what you're going to see later is that when you push a value back into the generator, that whole yield expression gets replaced with the value that you put back in. And this is the key. This is the recipe to allow you guys to write code that looks like it blocks, but actually waits. So let's take a look at how this works. We have this spawn function, which I'm going to define in just a moment, but think of that as the consumer. It's pulling promises out of this iterator of promise. So if I run this, what spawn's going to do is it's going to produce a promise, which will be the eventual result of getStockPrice, after we've resolved the getStockSymbol promise and the getStockSymbol price promise. And so when I run this piece of code, eventually it's going to yield the price of an individual stock, in this case Pfizer's stock. So how does this all work? Well, asynchronous iteration works this way. It's the same as iteration. You got a consumer and you got a producer. The consumer requests a generator from the producer and then calls next, pulls out the first value. But notice, execution suspends at the first yield. And what we're yielding back is a promise. It's a promise that will eventually resolve to the symbol for Pfizer. And so that promise is handed to the consumer. And the consumer and the producer have an agreement. The consumer says, every promise I pull out, I'm going to resolve, and then I'm going to push the value back into the producer. So the consumer calls then on the promise, waits until it's resolved, and then calls next again on the generator from the producer. Except this time, notice, we pass PFE in the argument position of next. We're effectively pushing a value in at the same time as we're pulling a value out. So we send PFE back in, and now I want you to look at what happens to the yield expression. It effectively gets replaced with the value that we get pushed in, and then execution resumes and pauses at the next yield. So now the consumer's pushed in a value, and at the same time they're pulling out another promise, this time for the price of that particular stock. So agreement between the consumer and the producer. The consumer is going to resolve that promise, and when it gets a value, it's going to call next again, and this time push 2783 back into the producer. That replaces yield, and we continue and stop at the final return value. So now we've actually returned, it's not a promise, it's just a plain old value, back to the consumer, and we said, hey, we're done, we're not going to give you any more data. At this point, the consumer takes that promise that it returned, the spawn function, and it resolves it to the final value, 2783. So pictures are great, but let's take a look at some code. So here I have getStockPrice, and then I have this spawn function which consumes it. So notice at the bottom, I'm calling spawn, but I'm passing in the generator that comes out of getStockPrice into spawn. And what's going to come out of that is a promise that is eventually going to resolve to the final price of that stock. So I run this, and what happens is we immediately create a promise inside of the spawn function. And execution runs to the very bottom, and it hits this onResult function. And this onResult function is just basically my way of asynchronously looping and continuing to resolve promises. You're going to see me recursively call this function again and again every single time I get a new value out of a promise. So this is the first time around, so we go up here, we call generator next, right? The last promise result is undefined, I haven't gotten any promises yet. And so as soon as I call next, notice up there at the top, execution stops at the first yield, and we return a promise that symbolizes the eventual stock symbol. And that gets returned to the consumer, and if it's a promise, the consumer calls then on it. And notice how here we're passing in the onResult function we started with. Except this time when the onResult function gets called, it's going to get the result of that promise. And so as soon as I do this, we're going to hop right back up here, and last promise result is going to be whatever came out of that promise, J and J. And so now I've got the result of the promise as the producer, but I want to push it back into the consumer. I want to push it back into the producer. So I call next. I pass back in JNJ as the argument. And if you look up at the top there, notice what happens to that yield symbol promise expression. It gets replaced with JNJ, and execution resumes and stops at the next yield point. And so get symbol price is a promise that eventually resolves to the price. That's what comes out to the consumer. Another promise, we call then on it again, pass in on result. That recursively gets called with the result of the last promise, which this time is the price. And so we do it all over again. We call next, yield gets replaced with that price, and then we continue on to the very end of the generator function, at which point it comes out and says, you know what, done is true. We're not going to get any more values. The consumer takes that, doesn't need to resolve it, it's not a promise, and then resolves the promise, the overall promise that was returned from spawn, to that final value. And that's how asynchronous iteration works. And that's how you can write code at the top, right, that looks like it blocks, but it actually waits. So there is this spawn function that's actually defined in a library that you can go and try, which is called task.js. So as soon as, if you are using a transpiler that allows you to use yield in your code, or you're actually using a browser that's ES 2015 capable, lucky you, you can do this today. Right? You just go ahead and download the spawn function, which is in task.js. So that's how asynchronous iteration works, and that's how generators interact with promises to produce this pretty impressive code. But, I mean, why should we have to download a library to do this? I mean, this is going to be such a common pattern in JavaScript of wanting to do a whole series of operations and just sort of pause until the asynchronous bits are done. Why do we need a library? Why can't we have direct support in the JavaScript language for this? And that is our first feature today from ES 2016, and it's async functions. And now you guys know everything you need to know about how async functions work. They are light sugar over what you just saw, this combination of spawn and yield. Soon, in the next version of JavaScript, you'll be able to write code like this on the left-hand side. So for those of you who are familiar with C#, this feature is in C# as well. You don't have to worry about generators or helper functions. You can just put the word async in front of any function. And then inside of there, anytime you want to pause until a promise has been resolved, you can throw in a wait in there. So that's what's coming in the next version of JavaScript. So we're getting closer to this vision of symmetrical support for blocking and waiting in JavaScript. Right? If I want to wait, I throw an async in front of that function. I throw a few awaits in there. Right? If I want to block, I take them out. Now, in order to talk about any features in the next version of JavaScript, responsibly, we have to talk about the ES feature maturity stages. So as we develop new proposals in the JavaScript committee, what we want to be able to do is move them through these maturity stages so we have time to prove them out. And so when I tell you about a feature upcoming in JavaScript, I'm going to tell you about which stage it is in maturity. So async functions are in the draft stage. So that means that the committee expects the feature to be developed and included in the standard. I think it's very, very likely that we're going to see async functions in the next version of JavaScript. So it's definitely something you can play with today if you're using Babel. Or a transpiler like Tracer. I believe you can play with this right now if you want to. So go ahead, try it out. That's why it's there in transpilers, and give us your feedback. So you can try async functions in Babel, actually. This slide's a little bit old, but if you want to try it in Regenerator as well. I believe they're now in the main branch. Sorry, the slide's a little bit old. I think Babel is probably the easiest way and the most likely way by which most of you are going to try this feature. So the await keyword makes it really easy to await one asynchronous value. But what if you want to wait on multiple values? Right? We await multiple values all the time. WebSockets, DOM events, there are lots of streams of information that are being pushed at us, and there's no real language support for traversing those streams of information. Now in ES6, all collections became iterable. And what the iterable thing is, it's a contract. The array, if you walk up to the array, for example, it means you can ask that array for an iterator and then gradually consume its items one at a time by pulling them out. So here's a good example, right? I can take an array and I can walk up and I can call this symbol.iterator method, and then I can get out an iterator and I can just keep looping and calling next. But that's kind of annoying. That's a lot of boilerplate, which is why in ES 2015 we introduced this new for-of loop for consuming any collection that happens to implement the iterable contract. So there's a couple of new collections coming in ES6 as well, like maps, and you can use this to consume that data progressively. So that's what the new for-of loop is for. It just desugars to what you see on the left-hand side there. Now, if we can wait for values that we can pull out, for streams of values that we can pull out, why can't we wait for streams of values that are being pushed at us? Why can't we have an equal support, like a loop, for consuming data that comes out of a WebSocket, or data that comes out of Async I/O, for example? That's the logic behind the proposed for-on loop for the next version of JavaScript. So if you can have a for of, why can't you have a for on? So in this particular example, I'm creating an async function, and inside I'm actually consuming the prices from a WebSocket. And the very first price differential that's over a certain threshold, I'm going to resolve the promise and grab that particular diff between the previous price and the next price. No callbacks required. I'm just looping over a stream of information being pushed at me. So this would be great to do, right? Now when I run this, it resolves to a promise that gives me the next price spike in this stream of stock prices. But there's a little problem. There's a reason why we can't have nice things just yet, right? The problem is that the web has no standard observable interface. We have iterable. As of ES6, we have this iterable contract you saw earlier, what you call symbol.iterator. But today, we actually have this proliferation of different APIs that push us streams of data, that push us data in a callback in a sort of a streamed way where you get multiple values. DOM events, WebSockets, server-sent events, send interval, node streams, XML HTTP requests, all of these things can actually push you multiple values. But they don't implement one common interface. So one thing that's proposed for ES 2015, or 16, excuse me, is the observable contract. So here we have the iterable contract introduced in ES 2015. How are we going to get the observable contract? Well, it's actually hidden inside of this type. In fact, if we just swap the arguments and the return type of the iterable, what pops out is an observable. An observable accepts a generator and then uses the push side of the generator and pushes multiple values into it until it finally calls return to signal that no more values are coming. If you think about it, iteration and observation are both about the same things. They're both about a producer giving a consumer multiple values. The difference is, in one circumstance with DOM events, the data is being pushed to you. But when you're using an iterator to pull values out of an array, you're pulling values, right? In iteration, the consumer's in control, and in observation, the producer's in the control, right? The WebSocket decides when it calls you. So it's sort of like they're iterating you, right? The producer's iterating you by calling your callback. So how does observation work? Well, we know consumer and producer in the relationship here with an iteration. It's the exact same process, but kind of the inverse. So here, the producer, instead of the consumer requesting a generator from the producer, the consumer hands a generator to the producer. And in this context, just think about a generator as like three callbacks, right? It's got the next, the throw, and the return callbacks. So it's just sort of like you're handing an API three callbacks and expecting it to push information to you by calling your callbacks. And so the producer produces a value and calls the next method on your generator, the one you provided to it. And that's how it pushes 42 to you. And then produces another value, and at its leisure decides to push 39 to you, until finally it says, you know what, there's no more data coming. And so it calls return to indicate to you, no more data will arrive. So observation and iteration are actually deeply linked. As we saw, we just turn one inside out and we get the other. And so this is what it would look like to consume a WebSocket or a DOM event that implemented this contract. You could just walk up to any of these data sources and hand it a generator, which is just these three callbacks, and then it will just push streams of data at you until it tells you it's done. So we can add sugar, just like we added sugar for iteration, for that whole process of calling symbol.iterator and that while loop and checking the done property. Just like we can add sugar for that, we can add sugar for observation. We could add like a for each method, for example, to an observable that returned a promise when it resolved. Or, as I showed you guys earlier, now that we have a well-defined contract for observation in JavaScript, if we do, we can add a for on loop. So consuming data from a push stream can be done entirely without callbacks. So the hope would be that if we introduce observable, all the push APIs out there on the web can implement this contract, and then all of a sudden we can just add language support magically for all of these different push data sources. So if I wanted to consume an observable in ES 2016, at least as the proposal stands, I could do something like this. And this is just going to keep printing out new signups at Netflix. I'm just going to keep going. So if an async function returns a promise, and a function star returns an iterator, we as language designers have a question to answer. What does an async function star return, right? You can't just go adding features to languages and not describing what happens when you put them together, when they interact. Right? Well, there's a couple of different opinions about this. And there's actually couple of different ways the committee could go. But I'm here today to tell you about one particular option. So if we look at this table, we've got synchronous functions, which return a value. We have synchronous generators, which return multiple values, right? You can pull multiple values out of. But we also have asynchronous functions, which return a promise. And a promise pushes you one value, right? You give it a callback, and it pushes you a value in that callback. But what goes here? Well, if a function star returns multiple values, and an async function pushes one value, maybe an async function star pushes multiple values. And what type pushes us multiple values? An observable. So we could envision, in the next version of JavaScript, an async function star which pushes you, which actually returns you an observable. So you could build a asynchronous generator function which consumes data, stock data, for example, and then translates it and produces new stock data. So I want to now, instead of just getting the next price spike from a WebSocket, I want to get all the price spikes from a WebSocket. I'm actually going to use the for-on loop, and I'm going to use yield inside of async function star, and this whole thing is going to produce an observable that pushes me all the price spikes, all the stock differences. When one stock comes along and another stock comes along, and that price difference is over a certain threshold, it's just going to push it on through to me. And if I wanted to consume this, I could just use for-on inside of an async function and print it to the console. So what does that mean? It means symmetrical support for functions that return multiple values, whether they're push or they're pull. You guys can stop worrying about the machinery and the callbacks and just focus on your code. So this particular proposal, I just want to call out, is at the straw man phase. It is the earliest stage of the process, and so we're definitely going to be thinking about this more, and this may not make it through as a final feature, so I just want to make that clear. It's very early in the feature stages. We're looking for feedback on this, right? So we want to hear from you about whether this works for you and solves your problems. So thanks very much, everybody. Here's some resources for you, and that's the end of my talk.